let's identify one of the important concepts of looping structure, that is nested loops. What exactly we mean by nested loops? When a loop appears inside another loop, we call that as a nested loop. Now, no hard and fast rule that the two loops are supposed to be of same type. You can have a while within a do while, you can have a for within a while, you can have a for within a for, you can have a while within a while also. So when a loop appears inside another loop, we call that as a nested loop. Now let's see how a nested loop works. So that's the basic definition. When a loop appears inside, or when a loop executes inside another loop, we call that as a nested loop. So let's put this particular example and try and illustrate the operations of this particular loop. Suppose if I have a for loop which says I equals to 1, I less than equals to 3, I plus plus. Within this for, I'll have one more for, say j equals to 1, j less than equals to 3, j plus plus. And let me have a printf instruction at this place. I'll say printf percentage d comma I, and let me have an instruction as printf say /n. I have a simple for loop at this place. So here a j loop appears inside the I loop, hence we call this as a nested loop. Now how this loop operates? What will be the output of this particular code? What will be the memory values of these variables? Trace this particular arrows and identify how the loop works. So this is the start point. Now wherever the arrow seems to be too lengthy to draw, I'll use connectors for them. Trace this particular structure carefully. So I is 1, go to this particular condition. So when I is 1, it will test the condition 1 less than or equal to 3, true. If this is true, it says execute this particular instruction. Since the condition is true, you said execute this particular j equals to 1. So when j is 1, it will again go to the condition of j 1 less than or equal to 3, true. If this is true, it says execute all the instructions which are there within this and then go back to j plus plus. So what is the value of j? So I had used I at this place. So what is the value of I? So initially your I is 1 and your j is also 1. So printf I. So now I will print 1 at this place. Then after j plus plus, the control goes to this particular place. So now who is going to change? J is going to change. So j is now modified to 2. Now say, when j undergoes a change, will it affect the value of I? No, the value of I is not affected. So follow these arrows carefully. So it starts, then condition is tested, and then j is 1, j less than or equal to 3, true. Printf percentage d I. After executing, go back to j plus plus, j is now 2, 2 less than or equal to 3, true. True in the sense, again print to this particular I. So I is still 1. I is still 1. So it will print 1 at this place. And then again go back. When you go back, j becomes 3. So when j is 3, 3 less than or equal to 3, true. Print I. I is still 1, so it will print 1. If j would have been used, then probably the output would have been 1, 2, 3, because j is changing from 1 to 3. This is when j is supposed to be printed and this is when I is supposed to be printed. So now go back, j becomes 4. When j is 4, automatically the loop terminates. This is false. If the condition j less than or equal to 3 is false, in that case this will transfer the control. Let me use a connector at this place. This will take the statement x of this particular j loop. So from this place it will have a virtual connection to this. So now printf /n will get the cursor on next line. So now I becomes 2 in this case. When I is 2, this curly bracket will take you back to I plus plus. This is where the control lands. You can draw a complete arrow from this point to this point, or you can use connectors. So I plus plus. So I will now become 2. 2 less than 3, true. True in the sense, again j has to go from what to what? 1 to 3. So j has to go from 1 to 3, and all the time your I is 2 in this case. And if it is j, again j will go from 1 to 3. So again go back, I plus plus. So here j is 1, 2, 3, 4, stop, 4, stop. The same execution will go with I as 3 also. When I is 3, 3 less than or equal to 3, true. True in the sense, again j goes from what to what? 1 to 3. So it says 1, 2, 3. If I ask you to print j, and if I ask you to print I is 3 and 3. because when j is changing, it will not affect the value of I. So the value of I remains constant. If I ask you to print j value is printed continuously on the output screen. After that, when you go back, I becomes finally 4. When I is 4, automatically the loop terminates. Because you have used printf/n and this instruction, if this is false, let me use the connector C, and this is where I'm supposed to land. So when I is 1, 1 less than or equal to 3, true. True in the sense, go to j equals to 1. Go to condition, 1 less than or equal to 3, true. True, print I, go back, j plus plus. Then j less than or equal to 3. Again true, print and then go back. Keep on doing this particular operation till j remains true. So when j goes beyond this particular value, when j goes beyond 3, the condition will turn out to printf/n. And printf/n will take the control back to this particular I plus plus. So after executing this, again check the value of I. If it is true, again repeat the entire task. So keep on doing this task. At one point of time when I is false, automatically it quit. If you observe the changes, your I has changed less frequently, where j has changed more regularly. So j has changed for every change of value of I. These are the outputs when printf I is used, and these are the outputs when printf j is used. So these are the common applications or the common working of this particular nested loops. So if they ask you to write a short note on nested loops, the first thing which you should do is, what exactly mean by nested loop? When a loop gets executed inside another loop, we call that as a nested loop. And this is how the operation goes. You can have a for within a for within a while within a do while, any type of loop, and trace out the arrows. The most practical examples which we are going to use for nested loop is for within a for. Hence, I had illustrated this with for within a for. Follow the arrows carefully. Follow the arrows carefully. The arrows will tell us, or the arrows will indicate how exactly the loop has to work. Right? Observe the output. Write any one instruction in your exams and do write the appropriate output as per those instructions. I've shown the memory for just 2 executions. You can show the memory for even all the 3 executions. That is about the concepts of your nested loops. Thank you.